One of the roots of all evil is the sugar added to our food and beverages. Gary Brecka, life biohacker and ex-life insurance employee who predicted people's death to the month based on nutritional status, said one of the top major issues is controlling blood sugar. He explains here briefly. Glucose Balance X100 is here to help keep your healthy blood sugar healthy and under control.
Ask them various questions, and then you ask them about sort of biomarkers in their body. What are the simple biomarkers you think that everyone needs to understand? Because listen, I'm not a chemist, I'm not going to be a biologist,
Yes.
so if there's a couple of them, I can probably get my head around them and stay on top
Yes.
of them, but I can't stay on top of everything.
Yeah, so there I would say three.
Okay.
Number one is what's called glycemic profile, which is a check of how well your insulin and sugar metabolism is.
Yep.
And it has three markers: glucose, hemoglobin A1C, 3-month average of your blood sugar, and insulin. So definitely your glycemic profile, because blood sugar, I promise you, is the root of all evil. So first, I would do your glycemic profile. Second, I would do your hormones.
Can I just check on the glycemic profile? That's basically my relationship with sugar.
That's your relationship with sugar. And it's also your relationship with insulin, because very often, even people that don't eat high amounts of refined sugar and Ben & Jerry's ice cream every night have issues with insulin sensitivity. And so as insulin rises, it causes a whole myriad of conditions. It's one of the hallmarks of something called metabolic syndrome, which we're seeing in younger and younger populations. And it's generally easy to catch early on. You have three markers that look at how well you're regulating your blood sugar: glucose, which is a measure of the amount of sugar in your blood right now; hemoglobin A1C, which is essentially a 3-month average of your blood sugar; and then you have your insulin. And the higher your insulin relative to your blood sugar, the more insulin resistant you are, right? So the more insulin it takes to drop your blood sugar, the more resistant you are to insulin. This is an early warning sign of metabolic syndrome. But it's not just the metabolic syndrome, it's that when insulin rises, there's a whole downstream cascade of events, because insulin is not just responsible for helping us metabolize sugar, it's also responsible for blocking other forms of energy use in the body, one of which is fatty acid metabolism. And so generally people that have very high insulin have very high blood triglycerides. They have high blood fat. And high blood fat and elevated cholesterol are other markers for cardiovascular disease. So by actually bringing down one biomarker, you have a positive effect all the way downstream. And I would say, if you're only going to look at three things, I would look at your glycemic profile, your blood sugar and your insulin and your hemoglobin A1C, hormone panel.
Okay.
So looking at your hormones, and then specifically looking at what contributes to healthy hormone production: DHEA and a protein called SHBG. And then I would look at basic nutrient deficiencies: vitamin D3, magnesium, potassium, and vitamin B12, which are on most blood panels. And that is a great place to start to get the basics. How am I regulating my blood sugar? Are my hormones balanced? What nutrient deficiencies do I have? And then the second piece of information I would get, which you only do once in your entire lifetime, is a methylation test. And these are widely available, all over the world. I'm sure they're very easy to get in the UK. And you want to look at 5 genes: MTHFR, MTR, MTRR, AHCY, and COMT.
And just to be clear, so I can dumb this down for myself here,
Mhm.
those 5 genes relate to how my body processes the things that I put into it at different stages in that sort of processing line.
Yes, I mean, so to take, for example, that gene at the top, COMT. If you look at what COMT does, it stands for catechol O-methyltransferase. So it's a fancy way of saying it transfers a methyl group from the category of neurotransmitters called catecholamines. And that's a huge mouthful, but essentially what this means is these 4 neurotransmitters that are called catecholamines are responsible for our fight or flight response. So, for example, if you drove home tonight and you got out of your car and somebody was standing in front of you with a knife, right, you would instantly have a fight or flight response. Your pupils would dilate, your heart rate would increase, your extremities would flood with blood. You would begin to have a fight or flight response based on that stimulus. But you could also be laying in your bed at night and you could start thinking about getting eaten by a shark. And you could have the exact same response. because the brain doesn't really know the difference between perception and reality. The similarity between these two events, a very real fear and a reaction to it, and an imagined fear, is they both meet at catecholamines. It's a rise in the same class of neurotransmitters. So now some people are very slow to break these down. And what are the consequences of this? Well, if you've ever had anxiety or know somebody that suffered from anxiety, no one really tells people that have anxiety what it is. They describe the feeling. So they say it's a fear of the future. It's a sense of impending doom. It's a sense of anxiousness. But what is it? Physiologically, what's going on in the body? Well, very often it is a rise in catecholamines, the same class of neurotransmitters that are involved in a fight or flight response. And this is why very often people that suffer from anxiety don't have a specific trigger they can point to. They could be on a podcast like you and I are doing right now, and all of a sudden as those catecholamines rise, they get that sensation of anxiety, and they're trying to pin it on their outside environment. They're trying to look for a cluster of symptoms outside their body. But this is because they are deficient, usually, in a complex of B vitamins, a very specific form of B12 called methylcobalamin, methylfolate, these methylated nutrients that down-regulate these catecholamines.